Drilling. An exciting and demanding job. A job that involves a lot of people and tons of equipment. But boiled down to its most basic, drilling mainly requires two things: a rotating bit and circulating drilling mud. A top drive is one way to rotate the drill string and bit, and powerful pumps circulate mud down the drill stem and back to the surface. In this program, we'll concentrate on mud circulation. Mud is the pit watcher's concern. It's in the hole where mud does most of its work. It jets out of the bit and carries cuttings to the surface. Also, mud cools and lubricates the bit and keeps the borehole from caving in, and it holds formation pressures in check. Holds formation pressure in check. That's right, a hole properly full of mud that has the correct weight or density keeps formation fluids that are under pressure from entering the hole. Water, oil, or both form the base of most drilling mud. Rig crew members add clays and minerals to the basic liquid to give it desirable properties. One is the mud's weight or density. To find out a mud's weight, you can use a mud balance. First, let's watch a crew member weigh clear water. Looks like the water weighs a little more than 8.3 pounds per gallon. This mud balance is correctly calibrated because clean fresh water weighs 8.33 pounds per gallon. Now, let's watch him weigh a sample of drilling mud that has clays and weighting material in it. This particular mud weighs about 14.6 pounds per gallon. Mud weight is important because the more mud weighs, the more pressure it exerts on the bottom of the hole. For example, clear water that weighs 8.3 pounds per gallon exerts 0.4316 pounds per square inch per foot of depth. So here's a hole 1,000 feet deep full of water. The water exerts 431.6 psi at the bottom of the hole. Here's the 1,000-foot hole again, but now it's full of mud that weighs 14.6 ppg. 14.6 ppg mud exerts 0.7592 psi per foot. Thus, the pressure on the bottom is now 759.2 psi. The heavier mud exerts over 300 psi more than clear water. But what if the mud is not dense enough? Its weight is too low and it doesn't develop enough pressure to offset formation pressure. Formation fluids flow into the well. This is called a kick. Or what if the hole is not full of mud of the proper density? Same as before, formation fluids enter the hole. The well kicks, and if the rig crew fails to control a kick, the well could blow out. Nobody wants this to happen. It's dangerous, costly, and should never occur. And here's the thing. If you're assigned to watch the pits on your rig, you play a big part in preventing this. So, pit watching is an important job. In this program, we'll cover the responsibilities and duties of the pit watcher. In a nutshell, the pit watcher's main job is to observe, record, and report to the driller any changes in what's going on with the mud. The duty station is around the mud tanks, or pits as they're commonly called. To better understand the job, let's look at the basic parts of the mud circulating system. First, the pump sends mud through the discharge line, up the standpipe, into the rotary hose, and through the top drive. Mud then goes down the drill string and out of the bit, where it picks up cuttings and cools the bit. Carrying cuttings, the mud moves up the annulus, the space between the drill string and the bore hole. At the top of the hole, the mud flows into the return flow line. It then falls through the shale shaker and into the first mud tank or sand trap. The shaker helps condition or treat the mud by removing larger cuttings. Once in the tanks or pits, the mud may go through a desander, a desilter, and a degasser before going down the hole. Sometimes it goes through a mud cleaner and centrifuge too. For details, let's start at the shale shaker. This vibrating set of screens removes cuttings from the mud as it returns from the hole. It's the first piece of cleaning equipment the mud encounters after it leaves the mud return line. It's something like a big sifter or sieve. For the shaker to do its job, you have to keep it properly adjusted. Here's how a properly adjusted shaker looks. The last of the mud falls through the screen near the end. Virtually all the cuttings are running off the screen. No mud flows with the cuttings off the screen. It's easy to correct problems. First, adjust the flow to decrease the amount of mud flowing over the screen. Then, increase the flow a little at a time. Increase flow until the last of the mud falls through just before the screen's end. The cuttings will fall off the end of the screen. Keep your eye on the cuttings. What you're looking for is changes, like a change in size or shape. They get smaller or bigger, or a change in the amount, more or fewer cuttings than before. Cutting changes indicate downhole changes. Maybe the bit has simply penetrated a new formation. But it could also be that a kick is about to occur or has occurred. After the shaker, the mud may flow through a degasser. It removes small volumes of gas the mud picks up from a downhole formation. The degasser removes the gas before the mud goes back down the hole. You need to know how to turn it on or off as instructed by the driller. Be alert for gas cut mud. It has a bubbly or frothy appearance. Notify the driller if you see it. He may have you turn on the degasser. Don't recirculate gas cut mud. The gas can cause the mud pump to gas lock. A gas lock pump cannot pump efficiently. What's more, gas lowers the mud's weight. Thus, recirculating gas cut mud could lead to a kick. After the shaker, the next piece of cleaning equipment the mud may go through is a desander. After the desander, mud usually goes to the desilter. Both remove small solids from the mud that fall through the shaker. The desander removes larger particles, the desilter the smaller ones. Both work the same way. Mud enters through the side, hits the cone, and rapidly swirls around like a cyclone or a tornado. Centrifugal force carries the heavier particles down through the bottom of the cone. Vortex action discharges the clean mud out of the top of the cone. You need to check the stream of mud leaving the bottom of the cone. It should look like this, a spray in the shape of a hollow cone. But this is wrong. The discharge is like a rope. To correct the problem, all you do is adjust the flow until it's right. A mud cleaner has hydrocyclones, like a desilter, but it also has a vibrating fine mesh screen below the cones. It removes almost all the solids from the mud except barite. Barite is a heavy or dense mineral added to the mud to make it weigh more. A mud with barite in it holds formation pressures in check. And actually, by installing an even finer mesh screen, a mud cleaner can remove barite from the mud. Barite's expensive, so it pays to retrieve it. Adjust the lever to keep the discharge in the form of a cone-shaped spray. Besides keeping an eye on the mud cleaning equipment, a pit watcher also needs to monitor the level of mud in the pits or tanks. Here's why. Mud circulates through a closed system. That is, the same mud circulates over and over. So if you see a gain or loss in the level of mud in the tanks, one of four things is happening. First, when the rig is drilling fast, when the rate of penetration, the ROP, is high, the mud level in the pits drops noticeably. The mud fills the increasing volume of the deepening hole. Second, something changes on the surface, like when you or other crew members mix, jet, or transfer mud. In such cases, the pit level may increase or decrease. It depends on whether you add to or take mud from the pits. Third, the hole penetrates a formation that takes mud. This is lost circulation. Consequently, pit level decreases as mud goes into the formation. Fourth, formation fluids enter the hole. The well kicks. Pit level increases. Formation fluids can enter the hole either during drilling or tripping. To summarize, 1. Fast ROP. Pit level decreases. 2. Surface changes. Pit level increases or decreases. 3. Lost circulation. Pit level decreases. And 4. Formation fluid entry. Pit level increases. Pit watcher, be aware of changes in pit level. If you ignore changes, serious problems can result. For example, a kick causes the pit level to increase. If not controlled, the well could blow out. So, if you detect a pit gain, an increase in pit level, and you haven't done anything on the surface to account for the gain, notify the driller right away.
So monitor our displacement going.
One way to check for a change in pit level is with barrel or cubic meter gauges like these. Another way is to hang a steel nut on softline near the mud level in the pit. Looks primitive, but it's fail-safe. So keep your eye on the level of mud in the pits and report any changes to the driller. You have to be especially alert to pit level changes when the floor crew trips pipe out of or into the hole. Keep in mind, a hole properly full of mud of the correct weight cannot kick. But if the mud level in the hole drops so the hole is no longer full of mud, the well can kick. With the hole not full, the mud doesn't exert the correct pressure. So when the floor crew pulls pipe from the hole, the mud level in the hole drops. It's just like removing a rod from a container of liquid. As the steel comes out, the mud level falls. It's very important to put mud in the hole to replace the pipe taken out. But here's another wrinkle. When pulling pipe, the drill string and bit can act like a piston in a cylinder. The bit pulls or swabs formation fluids into the hole. Swabbing is a lot like filling a syringe. The plunger inside the syringe is like the bit in the hole. The pressure drop created by the plunger or bit pulls the fluid right in. The hole may actually be full of fluid, but not uniformly full of mud. And the mix of mud and formation fluids does not have the proper weight or density. Swab in enough formation fluids, and the well can kick. So during trips, the driller keeps careful track of the amount of mud he put into the hole to replace the drill string steel. He compares the amount that the hole should take with what it actually took. the figures don't match, he knows he may be swabbing fluids into the hole. As a pit watcher, be aware that when the floor crew trips pipe, you need to keep a close watch on the level of mud in the pits. Report a pit gain immediately. Another pit watcher job is to catch a sample of mud and measure and record its temperature. Here it's 68 degrees Fahrenheit. Knowing the mud's temperature is important because certain muds perform best at certain temperatures. Also, temperature changes can signal the possibility of a kick. So, carefully measure and record mud temperature every 15 minutes during drilling operations. For the next measurement, pour the sample through the screen in the top of this special funnel. It's called a marsh funnel. At this point, all he's doing is filtering out any lumps in the mud sample. Now, get a stopwatch, your mud sample. You'll need a little over a quart or a liter, a graduated container to catch the sample, and the marsh funnel. You're going to measure